I want to show a few more things about object-oriented programming and do a little review since we've had a little bit of a break here, get our heads back into thinking about developing programs using this style. So as an example, I'm going to make a bank account class. And again, we have to normally think about, what is stored in an object of this class. And those are the instance variables, right? So what's the main thing about a bank account? We'll start with maybe just a balance. So how much money is in the account. I'm going to start off making this private, so only code in this class can access this instance variable directly. And I'm going to make it an int, even though really it should be like a double or something else, right? So we'll just work with whole numbers here. And I'm going to call this balance. Okay, so that's really the data in a bank account, and then there are the things that we have to do to construct a bank account and to have various services for it, and those are the methods, right? And the first one we like to make is the constructor, and so that is a public, the same name as the class, because that's the type of object it is, and it's going to take off some starting deposit, so some amount of money to start off the account. And the job of the constructor is to initialize the state of the object, in other words, the instance variables and any other kind of data associated with it, to some sort of consistent, reasonable state. So when we talk about the state of an object, you really mean the stored data in there. So I'm going to say the balance is equal to start deposit. Okay, now notice this is highlighted in a different color, right? So the blue is the instance variables here. This is the local variables and parameters. And once I've done that, I actually can make, one of these account objects. So I'm going to make a variable of type account. We'll call this a savings maybe, right? And I say it's a new account with, hey, give me $1,000 to start off. So, okay, if I run this, nothing's going to happen because nothing prints out or anything, but at least it doesn't crash or anything like that, right? Since main is actually in the class, in the public account class, I am allowed to access in here kind of directly that balance. So I can print out the savings dot balance and see the $1,000. Now, if this were public, let's just talk about the design philosophy here. That means code outside the class could access it. So if I was in a different file, not just putting this as a different file, and I had somehow had made a savings account object, because that's a public constructor, I can make that. I would be able to say savings.balance in this other file, right? And what's it complaining about here? Oh, it's just not a finished statement. I could say, let's give myself $1 million. And that would bypass any checks I have on this thing, right? So if this were public, code outside the class could do something like that. And that seems to me to be something you want to be able to stop. And so that's really, again, that kind of stuff is why we have private instance variables. So we can't do these things outside the class. Main is kind of a funny thing, right? Because it's in the class, but it doesn't really belong to the object. All right, what else do we want to do? We want to be able to change the balance in some sort of meaningful way. So I need a public method, and I'm going to make a deposit of some amount. Okay, what has to happen in here? Well, I'm giving some like $100, and I want to add that to the balance. Well, this method has access to the instance variables because it's all in the scope of the class. And so again, I could just say balance plus equals deposit. All right, I can change it. And let's do the same thing to withdraw money from here. Make withdrawal and withdrawal. And I'm going to say I'm subtracting. So withdrawal is like a positive number. I want to withdraw $100, so I subtract that $100 from the balance. Notice these are void methods, and that means, again, we're not returning a value. I'm not saying, hey, my new balance is $900 or something like that. All I'm doing is changing the internal state of any object that calls this thing. So here we have an object, savings, and I'm going to, make deposit of $100. And if I print out the balance after that, I can see the new balance. This withdrawal is kind of dangerous because what if I have $100 in my account? I want to withdraw 1,000. Banks don't generally let you do that, and in fact, they charge you more money if you do that. We're a nice bank. We're just going to stop it from happening in the first place. Okay, so I want to check if, as long as the balance is bigger than the amount I'm trying to withdraw, then I am allowed to do that activity. Otherwise, I'll do nothing, let's say. I could print something out maybe, but we'll get to that in a little bit. So let's try to withdraw from our savings. Make withdrawal $100,000. Sure, why not? And I'm going to print out the balance after that. Well, it's still $1,100 because I had $1,100. I tried to withdraw $100,000. I'm not allowed to. That's too much for the balance, and so I just did nothing there, right? All right. Let's see. What else might we want to try here? I don't like this. The only way to see the balance is for me to be inside the class and accessing this private instance variable. That's not a good idea. So I want some way to print out what's stored in here. I could have like a get balance, kind of method or something like that, but I might just try to use the Java sort of ecosystem here and use the toString method, right? So a toString method returns a string, and when you try to print an object, the toString method gets called. So whatever string, I put in here, and let's just put something, that you might not expect in here. And now if I try to print out just the object here, again, what happens in a print line? This really calls the toString method of this object, so this saving object toString, and it prints out whatever string is returned. So print it out, and I'm rich. Okay, it's like, well, that's not exactly what I want to know. So let's have a little more detailed information here. I'm going to have my balance and report on the actual balance. Okay, so now I get a little more, a little nicer output. And it's nice that I can just print the object even outside the class, right? Because this is a public method. And then this code has the access to the balance instance variable because it's inside the class. All right, and plus toString is a good thing just for every class to have, so you can do something sort of meaningful when you print out an object. Okay, so we have a couple cool things we've done so far. Let's do a transfer. All right, so first of all, let's make another account, a checking account, and it's a new account, and I'm going to put $500 in it. And notice again, this savings account has its own balance. The checking account has its own balance, right? The instance variable here, there are now two balances, one for savings and one for checking. And when you say something about balance here, the way that it knows which balance to use is because this method, this instance method, was called from an instance of the object. So savings.makeDeposit, when it calls makeDeposit and it asks what balance it has, it means the balance associated with savings. When I do it for the checking, let's do $10. It goes to make deposit. What balance is associated here? it is the one that's for the checking account, all right? So again, each instance variable has its own storage, one per object. Okay, now let's write our make transfer. I'm going to call this transfer to. In other words, it's from the object that calls the method to the account object that is passed in as a parameter. Destination. All right, so this is a void. So what has to happen here? Well, I have to take money from the object that calls. So let's see what this looks like. We're going to call from savings. I'm going to transfer to checking. Oh, and I need an amount. So let's change this. Transfer to int amount. How much is going to get transferred? Well, at the basic form, that amount goes away from the balance. So in this case, balance minus equals amount. Right? So savings calls the transfer to method. That means in here, balance refers to the savings object. In order to put it in the balance for destination, I need to qualify it and say, I want to use the balance associated with this destination object. Right? So you get one like instance variable for free, kind of, right? This is the object that called the method savings. And one way of showing that is that is this. This is the object that called the method. And if I have other objects in here, then I can use their name, the variable name, to say which one I want to use. Now, why am I allowed to access balance here? Well, balance is private to the class, but that does not mean private to the object. Any code in the class can access any instance variable of the account type. All right, so I can get to this balance because it is inside the class code here. I can't use outside in some other file, I can't use destination.balance to get to that because it's private, but in here it's part of the class. So that may seem a little funny, right? The division is not per object for private, it is per sort of file and class kind of level. But that makes it easy, I can get to that right away. I could have called destination make deposit, which is a public method, and it would do the same thing, right, with amount. And maybe if there's some checks in there, but I could use them like that. Okay, so that's kind of nice here that we have a parameter of the same type as the class that I'm in, account, but there's nothing too special about it except that I do have access to the internal private instance variables here. All right, let's do one more little thing, just make this a little more interesting. I'm going to create a log file. Well, not really a file. So every time I do a transaction, we should probably write it down somewhere, right? So that someone can kind of see all the things that happen. And this would probably be really a database or a file somewhere, something that is actually designed for storage. I'm just going to keep concatenating onto a string more stuff, and then we can print out the string at the end. So this is a real cheap and easy way of doing it, but it's not like a great way of doing it. So what has to happen in here? I need to initialize log. Well, what should it be? Well, it should be, I'm going to say something like the transaction log, then go to a new line and say maybe initial deposit equals, I'll say balance here. Right? And then every time I do something, I want to add to that log. Log plus equals deposit plus deposit, deposit, and then I'm going to add a new line at the end just so we don't get it all one big long line when we print it out. And down here, I'm going to do a withdraw one. log plus equals withdrawal. I'm trying to remember what kind of format I'm using for all this. Withdrawal plus a new line. And here I actually have a chance to have an else. So this was basically if we had enough money, right? If we don't have enough money, I can add to the log failed withdraw. And I probably should give the amount or something like that, but just, I'm not going to. So failed withdraw, like that. And we should log the transfers and stuff, but maybe I won't. Let's add a method so that people, I could, again, print out the log down here because it's in the class, but outside the class would have trouble with that. So let's add another method, public. This is a void. It's just gonna print out the log, and print out the log. Not much to it, but this is providing access to this private log variable. Because again, we don't want people adding fake transactions to the log, right? Okay, so here I'm going to print out the, let's say, savings. I don't want to print it out. I just made a thing for this. I'm going to say savings print log. Savings print log. Okay, phew. I always get a little worried there. Print it out. Initial deposit 1,000. Looks like I forgot a new line at the end of that. Initial deposit. And it's good to test these things and fix as it goes. So we had transaction log initial 1,000, deposit 1,000. I had a failed withdrawal for that big withdrawal I tried to do. And again, I should log this transfer too, but maybe I won't bother with that right now. Okay, so let's try something else. Let's say we want an account number for this thing. So every time we make a new account of some kind, we want to give it a number, like 1,000, 1,001, 1,002. And I don't have to remember it here because I might be calling it from all sorts of different files, right? So we need some kind of int that is accounts made or something like that, some sort of count. And the problem is that if I make this new for every instance of the class, then it's going to just start off at like 1,000, and then the next one 1,000, the next one 1,000, next one 1,000. So I need something that's shared between all the instances of the class somehow, and that is a static variable, or it's called the class variable. And I should make this public, maybe. Well, no, I can just make it private. Still inside the class. And so basically, this thing hangs around. It's associated with a class name. So I can say, for example, another code, accounts made. So notice it's from this class name, not from an object variable name here, right? And again, there's only one version of this variable. It's not like there's one per object. And so if I make it once and change it, then it persists for all objects. Now the question is, how can I initialize this thing? It's actually telling me something about, well, so it's not used. First of all, I'll point out that class instance variables are default initialized to kind of a zero-leg value. Unlike some other code, like local variables where you have to explicitly initialize them, they do start off at 0. But if I try to initialize it in here, every time this constructor is called, that would be reset to 1,000. So I also won't be able to gain new values. So we need some way of making it outside, excuse me, outside the constructor. I'm actually allowed to initialize it right here if I want. So here it's when the class is actually first read in, it's set to 1,000. And now I need to store the actual account number per account. So private int account number. I'm not going to initialize it here, but down here I'm going to assign it account number equals the accounts made. And then after that, I'm going to tell accounts made to go up by 1. Okay? So we start accounts made at 1,000. We assign 1,000 to the first account that's made. Accounts made goes up 1 to 1,001. Next time we call a constructor, it puts 1,001 in here. So let's change this one here. Account number, and the balance. And I'm going to print out savings, and I'm going to print out, well, let's put this together with the checking. So I'm going to move that down here. Savings and checking. I'm going to run this, bunch of stuff coming out. So when I print out savings, it's account number 1,000, balance 900. When I print out checking, it's account number 1,001, balance 710. And that's again because this static class variable hangs around one storage per class, and I can access it from any of the code in the class, even though it's private. And when I change it, it still just sticks around with the class, right? So that's what a static class variable is, one version per class, not separate storage per instance. Now I can also make a static method. And of course we've been doing this, like our early homework assignments were all static methods, right? And the main thing about static methods are you don't have to call it from an object of the class. You just call the method name. And you're not allowed to access any of the instance variables of the class because there's no instance associated with it, right? So a static method basically does not change the state of the object. All right, what kind of static method do we want to make? Sometimes they're called helper methods. Helper methods basically do little computations that aren't related again to an object, but just something related to the overall goal of the class. And I don't really have a perfect example here of something I want to do, but notice, like when I'm making the deposit here, I'm already assuming this is like a positive number, because otherwise that would be, sort of like going the wrong way and stuff. And we should have some check for that. And so I'm going to have a static method Boolean called validity check, and it's basically just going to check if that number is positive or not, some number, right? Int amount. And the question is also, should this be a public class or a private one? Well, let me just say, if its only really reason for existing is to help out other methods in the class, maybe this should be private. In other words, it can only be used or called from code inside the class. If it has some larger purpose, like it does some service for people that outside the class, then it can be public. But this one, this validity check, is probably private in the sense that I'm sort of checking some internal value here. So if the amount, and again, this is something that, it'd probably be okay to write this as separate lines, just little if statements in the code, is greater than 0, we're going to return true, it is valid, else return false. Okay, so this just checks if some amount is positive or not. Well, we're going to do that. We're going to say if the withdrawal amount is less than the balance and validity check on withdrawal, then do this stuff. And here we're also going to have the deposit if validity check on the deposit is true, then do these things. And if it's not true, we're not going to do anything, right? I guess we could log it again as a failed deposit or something like that. Now notice this method is using a value from the parameter here. It is not trying to use for example, if I try to do something with balance in here, add 1 to the balance, it's going to complain and say, cannot make, through a static method, I cannot reference a non-static instance variable or field balance, right? Now, the quick fix here says, hey, let's make balance static. That would be a huge mistake. Every account would share the same balance. Don't quick fix this stuff. Figure out why it's complaining. This is a static method. I'm not allowed to use instance variables in the static method. It's as simple as that. The job of this static method is to provide some service. A little chunk of code I don't want to repeat some, various places. And I'm only using values that are sort of independent of these objects, savings and stuff like that. Right? They're values that are passed in to these methods, but they're not part of the object themselves. Okay, so this is a little more complicated class than I think we've been looking at. We're storing a value in it. We store something that sort of gets used throughout in different methods. We're storing another value, and then we have this static class variable that basically allows us to do something over the collection of objects, not just the one instance at a time. We have our constructor that initializes the state of the object. We have something that allows us to do a deposit, something that allows us to do a withdrawal, something that involves another object of that same type as a parameter. So these two objects now working together, and one again is the instance variable for this, and one is the instance variable for the object that was passed in as a method. And another basic method, we have a static class method that does not get called from an object. In other words, I could call down here validity check on 100, and I don't need, savings dot in front of it or checking dot in front of it. I could say account dot in front of it, and I do need to do that if I'm outside of this class, but I don't need an object. And then we're using a sort of common method, the toString, which helps this object behave properly in the Java larger system. So if you print out the object, you get some meaningful information instead of just a reference number. Okay, so that's, again, a little review of sort of basic object-oriented programming, but maybe with a few new twists with the static stuff, and a few twists on perhaps, the static and this idea of passing in an object of the same type into a method and using both in the code. All right, that's it. Thanks.